Alright, so I'm sure that you've heard the term to neutralize something. So if I have an acid, I can add some base and that's going to make it neutral, or if I have a base, I can add some acid and that will make it neutral. So let's say I have hydrochloric acid and I'm going to add some sodium hydroxide to it, and I end up with sodium chloride and water. Okay. So if I do that, I should end up with a neutral compound here. But it's always possible I have just a little bit too much acid. And if I have too much acid, it's excess, and it's going to end up in the beaker or whatever container I have along with the solution, right? And if I have a little too much base to start, excess base, I'm going to end up with a solution that's basic here. So a lot of times I'm trying to figure out exactly how much acid or base I need to add so that I can end up with a neutral compound. Okay. Now every acid-base reaction is nothing more than a double replacement reaction. So HCl is going to break apart here. Sodium hydroxide are going to break apart here. The sodium ends up with the chlorine. The H ends up with the OH, and I end up with a salt, in this case table salt, and water. Okay. I can do the same thing with a different ionic compound. It's going to break here, it's going to break here. I'm going to have a double replacement. This ends up here, that ends up with the water. I balance it off and I have a double replacement reaction where I have made a salt, ionic compound, and water. Okay, always the same thing. An acid and a base are going to give me a salt and water. Alright, so let's say I have a problem where I'm trying to figure out how many milliliters of a specific acid need to be added to neutralize a certain amount of a base where I know the concentration. This is a typical chemist problem. Okay, so I'm going to do one of these using factor label, and I'm also going to try one using the M1V1 equals M2V2 that we used when we were doing solutions. So I'm going to start off with 125 milliliters, but because I'm using molarity, I'm going to change that to liters. So I've got 0.125 liters of sodium hydroxide. That's what I'm starting with. And what I know is for 1 liter of sodium hydroxide, based on the molarity, I know that that's 2.6 moles of sodium hydroxide. Oh, I'm going to have a balanced equation first. I know we had it in the previous slide, but I have HCl plus NaOH gives me NaCl and water. And the coefficient on all these is 1. So what I know is 1 mole of sodium hydroxide gives me 1 mole of HCl. Okay? And because I know the molarity of HCl, what I know is 1.5 moles of HCl gives me 1 liter of HCl. But I'm looking for milliliters, so I can do one more step. What I know is 1 liter of HCl is 1,000 milliliters of HCl. I take this and I plug it and I chug it, and I end up with 217 milliliters of HCl. Now the question is, does that make sense? Yeah, it makes sense because the HCl is a little bit more than half as concentrated, and if it's half as concentrated, I'm going to need twice as much. Okay, so it's about right. It's about right. Let's try another one. Alright, so this one asks how many milliliters of this acid would be necessary to neutralize this lithium hydroxide. So let's write the balance equation. I have H2SO4 plus lithium hydroxide. It's going to be double replacement. I'm going to end up with lithium. I'm going to need 2 of those. Lithium sulfate plus water, right? So I need 2 of those, and I need 2 of those. Okay? So what I'm starting with is 7.2280 grams of lithium hydroxide, right? And what I know is molar mass of lithium hydroxide is 23 0.95 grams of lithium hydroxide, give me 1 mole of lithium hydroxide. And that for every 1 mole, for every 2 moles of lithium hydroxide, right? For every 2 moles, I need 1 mole of H2SO4, right? And I also know, because of the molarity here, that there are 4.494 moles of H2SO4, and let's just go straight to 1,000 milliliters of H2SO4. Alright, if I do that and cancel all my units, I'm going to end up with 33.58 milliliters of H2SO4. Okay. So the way that I often do this in the lab is I start off with either an acid or a base, and I titrate it using this process of this burette here is a titration. I titrate it with the opposite. And if I have an acid as my unknown, I titrate it with a base of known concentration. Okay, and I can use that information, figuring out how much it takes to make it neutral, and I can do that, figure out what makes it neutral. I'll tell you in a second how to do that. I can figure out the concentration of my acid or my base. Okay, so here I have a sample that's being analyzed. I have this burette that's a very precise piece of glassware where I can measure volume very accuracy, and I fill it with sodium hydroxide that has a concentration that I know, and I put an indicator in, and the indicator will change color as soon as, let's say, this solution becomes basic. I start off with an acid, so I'm adding just enough so that as soon as it hits that slight pink, that I know that the color, that the acidity has changed over from being acidic to being basic, and that should be just about the amount of base that's going to make it neutral. Okay, so I add it slowly, drop by drop, until I get just that right color. And once I do that, I have the molarity of the base. I know how much volume it took. I know how much volume of acid I put in here, and I can use that to calculate my molarity of my acid. So let's take a look at an example. Let's just first show you how this works. This is what you're going to be doing in the lab. You add a solution from the burette. The reagent that's in here reacts with the compound. Let's say it's an acid in the flask. And the indicator shows exactly when I have neutralization. And I use that to determine the concentration of my unknown. Alright, so let's say I have this problem. I have 35.62 milliliters of sodium hydroxide neutralized with 25.2 milliliters of 0.0998 moles of HCl. Okay? So first thing again is I need to write my neutralization reaction. It's going to give me the same thing we had before, sodium chloride plus water. Okay. Now what I can do is start with how much acid it takes 25.2 milliliters of HCl, and what I know is 1,000 milliliters is 1 liter of HCl, and I know for every 1 liter of HCl that I have this many moles, 0.0998 moles of HCl, right? And that I know for every 1 mole of HCl I need 1 mole of sodium hydroxide. So this is going to allow me to figure out how many moles of sodium hydroxide it's going to take, or I have, and it's 0.00630 moles of HCl is what it took to neutralize the base. Okay? So what I know is molarity is moles over liters. So I've got 0.00630 moles, and I know it took 35.62 milliliters, so that's 0.03562 liters, and if I calculate that, I get 0.0. Oops. Oops, I was reading the wrong problem here. This molarity, or this number of moles here, should be 0.0025. I can't read my writing, but I think that's a 1 moles of sodium hydroxide. Silly me. Okay. So if I have 0.00251 moles of sodium hydroxide, and I divide that by the number of liters that I have, I'm going to end up with 0.0706 molar sodium hydroxide. Alright, you deserve another problem because that was a little bit messy. Alright. So in this one, okay, I'm trying to find the molarity of hydrochloric acid if 42 milliliters of 0.15 molar sodium hydroxide are required. Okay, so I'm going to start with figuring out how many moles by taking that 0.0420 liters of sodium hydroxide, and what I know based on the molarity is 1 liter of sodium hydroxide is 0.15 moles of sodium hydroxide, and that we have from the equation 1 mole of sodium hydroxide is going to be 1 mole of HCl. So what I know is, this is where I have 0.0630 moles of HCl. Okay? So what I want to find now is the molarity of HCl. Molarity is going to be moles of HCl over liters. My moles is 0.00630 moles, and my liters comes from here. That's going to be 0.100, and that will give me a molarity of 0.0630 molar HCl. Okay, and that's going to do it.